This is the multi-cycle video. I'm not the one actually, this is Cat Owens. I'm not the one actually responsible for the pipelining. I don't know it enough to demo it, so I'm just going to show what I was working on myself, just as a sort of backup process that I never finished. Slash did it for the study for practicing on the final. So the basics would be you have the four registers for the different stages: IF, ID, ID, EX, EX, mem, and mem write back or WB. Um, the control signals for future modules would be passed into each of them. So, for instance, IFID would store for JAL control, ALU source, ALU SHAMP control, branch, etc. It's not pictured here on the diagram simply for my own, for to make it more pretty and slash more readable. The jump and branch logic was a source of confusion for me. The diagram I was going off of initially was an older one that still had the jump mux over in mem stage. Um, in actual functionality, I would have moved all of this logic right here over to the ID stage and just put the comparator between these two like you've shown in other, I think the processor videos, or maybe it's parallel, not videos, parallel in the lecture slides. And that would give 0, and then you could calculate that and skip some more stalls slash flushes. Um, the other thing to note is that the this WA here and this reg enable would go into IDXE and then pass along. During write back, there would be those two would be passed in to these two. Because when you're writing back, you need to have the correct address to actually write in slash if you're writing in. Let me just control C that so later on we'll know. Other things to note that for this specific design, we had our controls for the operation mux and for the data mux to be controlled by the same logic, but because this is going to be operating and passing into the register, and this is going to be having to come take data from the register, GL control would have to be split in half, and these two muxes essentially have to operate independently from independent control signals. Let's see. This would be writing back to this for the standard, which means there needs to be a mux over here to intercept that. I hadn't figured out the logic for that yet, like how to code for that, but I knew it needed to exist. If we look over here, I'd started coding for it. Uh, you can see where I have like all the signals in the world here, and as you go down, it keeps having to pass on fewer and fewer control signals because you've used them up. Um, and that's pretty much my design. I did have hazard control in mind. For the data control issues, I would simply have had I was going to have it be able to write back from execution stage into the ID stage, shortcutting the last two stages in the case of addition and subtraction. A very simple calculation related um, commands. Uh, would have to watch out for a situation where you are. Actually, would that? No, actually, it should never come up. Anyways, this is the report. You don't need to see this. You want to see. Nope, 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 nope. Sorry, being bad. Um, the gel, oh, the flushes. That's what I wanted to talk about. For the flushing, each of these, the four registers between that separate the stages, I'd probably make have independent flush controls as well as independent stall controls. Although I'm pretty sure in practice, the only time when you're going to stall the system, IFID and IDEX are the only two you're going to need to stall. The other two are what you're essentially giving time for it to finish, or giving a gap between. I'm not 100% confident on that. I haven't done the charting for that. Similarly, flushing, I'm fairly sure only IDEX, EXMEM, and MEM, the write back would have to be flushed. I don't even think IDEX, this one, has to be flushed if I move this logic over to here. It simply has to be told to stall, so essentially not take in info. In fact, actually, that might be wrong as well. All this is a little bit, again, I haven't done the charting, so I don't know 100%. I'm aware there has to be mux over here since you're passing PC+4 back, and this jump mux back. I hadn't figured out the logic of how to do that actually, and it's something I really need to look at. But yeah, that is the theory behind it. I realized that this would have been week 2 and 3's work, but this is sort of a placeholder in case my group members who were in charge of pipelining don't make a video of the pipeline. I'm disappointed that I didn't get this lab working. The main contributing factors I would say was the FPGA bug, which just ate up so much time. I still haven't figured out how to get it working, and just suddenly being merged together with another two people. We just didn't have lines of communication open. We just didn't. Everything was a little bit frantic and hectic, and that was a problem for us. I hope to do well in the final, and I thank you for teaching for this semester. You're a good teacher, and I hope you continue on teaching for this class. That's it, and goodbye.